Dear students, this lecture is about Adams Bashforth Predictor-Corrector method to find a certain value of y for a specific value of x whenever a differential equation is given to you. The steps are the same as we have studied in uh, the previous method. The first one is you will be given a differential equation y prime, which is a function of x comma y, and three values of y. The starting values of y will be given to you people, which is already discussed in the previous lecture. If these values of y are not given, we need to find these values of y by any of these techniques. Third one, we need to find the corresponding values of the differential equation, the function of xy, and step size will also be given to you. And the most important is the formula, the predictor formula due to Adams. This predictor formula is due to Adams, and corrector is due to Bashforth. So the predictor formula is given by this equation: yn plus 1 is equal to yn plus h into fn plus half. These notation, you see, these are the backward differences, nebula fn plus 5 by 12, nebula square fn plus 3 by 8, nebula cube fn plus 251 by 720, nebula 4 fn, and so on. So this is the predictor formula due to Adams. Now the other one is the corrector formula. Corrector formula is due to Bashforth. So that is the corrector formula. The main difference between these two is the difference of these signs. This is plus and this is minus. Plus minus plus minus plus minus, and secondly these subscripts. This is fn and that is actually fn plus 1. So this is the major difference in all these differences as well. And the third one is these two coefficients are same. There is a difference of 5 and there is a difference. We see that the difference here is actually that is 3 by 8, and this is 1 by 24, and this is 251 by 720, and this is 19 by 720. So 251 and 19 are different. 720 is the same. Here both numerator and denominator are different. So this is the formula for the corrector formula due to Bashforth. So these two, whenever these two values of y obtained from predictor and corrector are same up to a certain decimal places, then we stop the calculation and the answer will be the same as of these two. So that is the statement which I've just told you people, that whenever these two values of y obtained from predictor and corrector are same up to a certain decimal places, then we stop calculation. Otherwise we will continue using corrector formula, this corrector formula, not predictor formula, this corrector formula to get the required accuracy. Now how could we use this method to solve a question? We see that a difference table will be needed because backward difference operator is using here. So we will be using a difference table for these two methods, the predictor and corrector methods. This is an example. You are given a differential equation y prime is equal to 1 plus 2xy with these initial values. This is the value of x naught and this is the value of y naught. The question is, show that the series expansion of y and power of x as far as x5 is this one. We need to calculate, we need to solve this differential equation up to x5 by any of the method, by Picard method or by Taylor series method or whatever, to get this answer y is equal to x plus 2. Actually this is the series solution, so we need to use Picard method or Taylor series method to get the series solution. Anyways, and secondly we need to tabulate the value of y and x up to 4 decimal places for this interval. X starts from 0 up to 0.3 with the step size of 0.1 by applying Adams-Bashforth method to compute y of 0.4. So anyways, you are given this differential equation. This is the differential equation, and x naught is 0, y naught is 0. That is actually x naught, which is 0, y naught, which is 0. So using 3 approximations of Picard method, which we have studied, that how could we use Picard method to generate this required solution, that is the solution up to x5. There will be no need to calculate this thing in your papers, because these are actually two questions. There is no need to calculate this series, but the question, this is an example of your book to find the series expansion of this differential equation. Anyways, you can use Picard method. Just go back and listen to the lecture containing Picard method. Listen the lecture carefully, or you can also check the example by Picard method in your book, that how could we use this method to get this series solution. Anyways, this is series solution, and the following table shows the various values of yn and fn along with differences. We see here that these are the values of x, these are the values of x, because we see here that x starts from 0 up to, and starts from 0 and the end is 0.3 with a step size of 0.1. So the first value of x is x naught, which will be 0. The second value of x will be x1, which is 0.1. The third value of x will be x2, which is 0.2, and x3 will be 0.3. So x naught is 0 and x3 will be 0.3. So these are the values of x. Whenever you put these values of x and this equation, whenever you put x is equal to 0 here, you will get y equal to 0. Whenever you put x equal to 0.1 here, you will get y1. Whenever you put x equal to 0.2 here, you will get y2, and whenever you put x is equal to 0.3 here, you will get y3. So these are the values of x and these are the values of y. Now just look at here, y prime is equal to 1 plus 2xy. This y prime is actually function of xy. This is the function of xy, 1 plus 2xy. So putting the values of x, put x equal to 0, and from here y is equal to 0, x naught is 0 and y naught is 0 here, you will get f naught 1. Now x1 will be 0.1, y1 will be here, which is obtained by putting x equal to 0.1. So you will be able to get f1 is 1 plus 2 into x1 y1. So this table is obtained in that manner. These are the values of xi's. X naught starts from 0.0, ends at 0.3 with a gap size, with a step size of 0.1, 0.1, then 0.2, then 0.3, and y0, y1, y2, y3 is obtained. And this is the function 1 plus 2xy, actually 1 plus 2xy. So whenever you put n equal to 0 here, you will get f naught is equal to 1 plus 2x naught y naught. So 1 plus 2x naught is 0.0, y naught is 0.0000, you will get f naught. Similarly f1, f2 and f3. Now in these formulas we need a difference table, so construct a that is the first difference, that is the second one, third one and fourth one as well. So the first difference is f1 minus f naught, this minus that, which is this one. f2 minus f1 is this one. f3 minus f2 is this one. That is the first difference. Second difference is this minus that, which is this one. This minus that, which is this one. And the third difference is this minus that, which is this one. Now using now we see that is f3, that is f3, and that is nebula f3, that is nebula square f3, and that is nebula cube f3. Remember that f3 upstairs is nebula f3, that is nebula square f3, and that is nebula cube f3. Now using predictor formula due to Adams, that is predictor formula because we have computed the three differences, the third difference, so expand the formula up to third difference, and because we are going to find y4, y of 0.4, this y3 is actually y of 0.3. So the upcoming value of y will be y4, and y4 will be actually y of 0.4. So put n is equal to 3 in this formula, we will get this equation. Whenever n is equal to 3, that will become y4, that will become y3, and these will become f3. Now from table, y3, replace y3 by its own value, that is y3, this one. H step size 0.1, h is step size, which is 0.1 here, and f3 from table, this is f3, 1.1912, this is f3. Nebula f3 is this one, that is nebula f3. Nebula square f3 is this one, which is nebula square f3. And nebula f cube, nebula f cube, nebula cube of f3 is 0.0049. This is nebula cube f3. So nebula cube f3 is this one. Calculate this sum, we will get y4 is equal to 0.4453. So remember that y4 is equal to 0.4453 by predictor formula, sorry. So y4 is actually y of 0.4. Now using at the same way, calculate the value of the function for x4 and y4. The function is 1 plus 2xy, so f4 is 1 plus 2x4 y4, replacing x4 by 0.4, and y4, this is the value of y4, which is 0.4453. Calculate this sum, we will get f4, which is 1.3562. This is f4. Now that is the same table in the previous slide, the same table, but we have added the value of x4 and the value of y4. This is the value of y4. In the previous table we have added the value of x4 and the value of y4 and the value of f4 as well. So these are the additional values. for this additional value, find the difference. This minus this is that, this minus this is that, this minus this is that, and this minus this is that. So this is a new difference table. You see that this is F4, so that will be nebula F4, that will be nebula square F4, nebula cube F4, nebula 4 F4. Using the corrector formula due to Bashforth, that is the corrector formula, and put n is equal to 3 here because we need y4. So whenever we put 3 here, we'll get y4 is equal to y3 plus h, f4, 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 and f4. The table goes up to 4th difference, so expand the corrector formula up to 4th difference. Now all these values are these values from here up to there. So replacing these values, replacing y3 by its own value, which is 0.3186, replacing h by 0.1, replacing f4 by 1.3562, nebula f4 0.1650, nebula square f4 0.0560, this is nebula square f4, nebula cube f4 0.0091, that is 0.0091, nebula 4 f4 is this one 0.0042, which is 0.0042. Now calculate this sum, we'll get y4 is equal to 0.4455. Now this is very much important. You see that y4 from the predictor formula is 0.4453, and y4 from corrector formula is 0.4455, that is 53, and this is 55. These two values of y4 do not agree up to 4 decimal places. These values are not same up to 4 decimal places. The last value is different. This is 5 and this is 3. So we need to continue using corrector formula. We need to continue using corrector formula, but how could we use this formula? By that is the same formula, but we need the new value of y4, that is the previous y4. You see, this is y4 0.4453, this one, and this is f4, the previous f4. This f4 is 1.3562. So we need to replace these two values. When we use the corrector formula again, we need to replace these two values by the newer one, the new values. The new value of y4 is 0.4455, so we need to replace this by 0.4455, and we need to calculate f4. In the coming slide we'll be going to calculate f4, and this f4 will be replaced by that value. So just look at that. y4 is 0.4455. Calculate f4, the new value of f4 1.3564, and that value of f4 will be using in this table. You see, that is the same table, but we have replaced the value of y4 by the newer one, and the value of f4 by this new value of f4, and calculate the difference, the first difference, the second difference, third difference, and the fourth difference. Now again, using the Bashforth formula, this is the Bashforth formula again. using the values, put n is equal to 3, the same way we'll get the same formula, but with new values of y3 is the same, that is the old value, but new values of f4, nebula f4, nebula square f4, nebula cube f4, and nebula 4 f4. These are the values. This is f4, this is nebula f4, this is nebula square f4, this is nebula cube f4, this is nebula 4 f4. So replacing these values, we'll calculate y4 is equal to 0.4455. Now just look at this value of y4. This value of y4, which is 0.4455, this value and that previous value of y4, these two values agree up to 4 decimal places. These two values are same up to 4 decimal places. So the values of y4 agree up to 4 decimal places. So y4, which is actually y of 0.4, is the same value, which is 0.4455. So that is the way to use Adams Bashforth predictor corrector formula.